Welcome to your first flipped video.
Hola!
Okay, so what you need to do is create a new page in your science notebook. Actually, I'm going to grab my science notebook real quick.
If you are supposed to be putting this in your table of contents, which my kiddos are, make sure you do that.
My kids, sorry.
And then you need to make sure that you put the page number down that it's going on.
Okay, so you're going to start a brand new piece of paper to not share with the one next door, and it's going to have that title, Properties of Magnets, on top. Look at the board. There's a date, or find the date somewhere, and then write the date next to it also. With titles, we like to make them stand out, so you might want to like highlight it or underline it.
Yeah.
Okay. So with the video and all videos, feel free to pause us or to replay us as you need to. Do not mute us. If you mute us, you're missing what we're telling you.
Yep, we don't say just what's on the screen. We give you additional information, so it is to your benefit to listen to all of our words, because all of our words are important.
And they're glorious. Okay, so your first definition. When you write your notes, you're going to want to write exactly what we have on the computer, or your tablet, whatever. And you're going to want to put like little dots for bullets or something, or maybe you can number them, put little stars. And now you're going to want to put the word. So the first word is magnet. Since this is a vocabulary word, your brain needs it to stand out. You're going to want to highlight it, underline it, maybe switch colors of pens.
Yep. So magnets, you guys are all very familiar with magnets, but what you may not know is that magnets are materials that are attracted to iron. So they don't pick up every type of metal. They pick up things that specifically have iron or contain iron in them.
And that's easy to try. Just try it with a gold ring or silver ring. It doesn't attract. Okay, so there is a part of a magnet. So if you look at a magnet, the magnet has ends called poles. And the poles are just the very tippity ends of the magnet. So this one has two poles. And on the screen you can see a better picture because they're color coded. So you can see red for south and N for north. If you face like poles, so two norths or two souths together, they will repel.
But if you have two poles that are opposite, so a north and a south facing each other, they will attract, okay? And when Miss Mills and I were younger, there used to be a song about opposites attract. And
take 2 steps forward, I take 2 steps back. And we come together because opposites attract.
And you know.
Look up Mariah Carey.
No,
she was
wrong. Paula Abdul.
Paula Abdul. She was cooler than I was when we were kids.
Okay, make sure you have all that down. Pause it if you need to. We're moving on.
Those two pictures would be good for your notebook. Okay, magnetic force. You cannot see the force, just like with Jedis. They can't see the force, but they know the force is within. The force is the actual attraction or repulsion. Repulsion is like pushing away between the magnetic properties. I threw this picture up because
Earth has a magnetic field. Is that what you're going to say?
Oh, no. You can buy this at the store.
Oh, because it's floating.
It's floating.
Got it. Okay.
You can't see anything. There's no pull there. But the makers of this globe put magnets at the bottom and here and in the globe, so it's actually pushing it, like repelling it.
And if you take two magnets, you can feel them pull together. And if you flip it so that like poles are together, you can actually feel them push when you try to combine the two. So even though you can't see it, you will be able to feel it.
Okay, the field. The field is different than the force. The force is what attracts you and brings you within. The field is just the area which you could attract.
And a field surrounds every single magnet. A force is only there if you have two magnets within close enough proximity of one another. That means close together.
So here's your definition, area of a magnetic force around a magnet. Draw this picture. So pause the video, draw the picture.
So there's a couple things to note in this picture. One, you should see that the circles have arrows on them. So you have the magnetic force or the magnetic field, coming from the north side of your magnet and going around to your south end of the magnet. Okay? So that's really important to pay attention to.
Very good. So every magnet, no matter the shape, if they're like rectangles or circles, they all have a field. And they start doing stuff when things get in that field. They'll start attracting them with a force.
And your magnetic field is always going to be strongest at your poles. Even though the whole magnet has a magnetic field, it's not as strong in the middle of your magnet as it is out towards the end of it.
You look at this picture, it makes sense. Look how close those lines are. The closer the lines, the stronger it is. This has no lines, so it's not very strong. Okay, so now something funky happens. If you take two magnets together or more, the fields overlap. And so we kind of expect you to know what those fields look like. So we're going to show you one at a time. Here's when two poles are attracting. They're liking each other. So the north's like, hey south, how's it going? And she has his field lines going towards the south pole. Eventually, that north is going to suck over that south pole and they're going to be attracted.
And once again, remember, take a look at your arrows. Your arrows are coming from your north pole going towards the south pole.
So draw this in your notebook and label it unlike poles, or you say opposite if you prefer that. And then here's the next one.
So this is what happens when you have two like poles. Our picture represents north and north, but it would be the same thing if it was south and south. So north and north don't like each other. So instead of having your lines connecting the two magnets, they're actually pushing away from one another, and they're traveling towards the south pole of their own magnet. So when you feel that push of your magnets trying to stay separate, that's because the magnetic field is actually pushing against one another like this.
So make sure you feel that next time you get to play with magnets in class, or there's a great website Ms. Burkhart found this summer that we'll have you go on too. You can kind of see those. So make sure you have that drawn in your notebook. And now we're getting to some trickier stuff. So that was all the proficient area of the standard, knowing how magnets interact and knowing opposites attract and likes repel. So now we're on more advanced content.
So now we're getting into the inside of the magnet, okay? We are not sure if you had this in 6th grade. We think you did. But atoms contain 3 different types of particles. They have neutrons and protons inside the nucleus, and then they have electrons moving around the nucleus.
Electrons are like hyperactive kindergartners on Red Bull. They're crazy little boogers that move super fast.
And each one of these particles has a charge. So a neutron is neutral, a proton is positive, and an electron is negative.
And right now, what we care about are the electrons.
Yep.
So we're going to take those electrons, and if they spin, they're crazy, they're really full of energy, and if they all happen to be spinning in the same direction, maybe in one direction, then you're creating a magnetic field, a teeny tiny magnetic field within that object.
So if you look at the picture on the left, where you see that it has 4 squares, and each square has a set of arrows in it, the arrows inside the individual squares are all facing the same way. But all 4 squares are not facing the same direction yet. So even though there's a tiny magnetic presence, that object doesn't have a strong enough magnetic field to actually attract anything
So it cancels each other out, basically. So each little square is the domain.
Yep.
So each square is a domain. Now look at the one on the right. All 4 domains, the arrows are pointing up. So that happens to be that all 4 domains, the electrons are spinning in the same direction, creating a pretty strong magnet. So these magnets that we're playing with here, all their domains must be pointing in a similar direction. Occasionally you might have one wonky, but the rest overpower it.
And anything that's not a magnet, so these arrows, so like your desk, for instance, will never be able to be a magnet.
No.
So these arrows inside these squares are pointing in all different directions, all random, all over the place.
Paper, glass, plastics, nothing is ever going to make them a magnet, not even Magneto himself. Alright, so let's take this a step farther. Here's what, if a piece of iron, like a nail, is usually made of iron or steel, which steel has iron in it. A nail is unmagnetized usually, and that's because it has domains. Look at those yellow arrows. It has domains. They're just going in various directions. But a magnet's made of iron also, and the domains are pointing in the same direction. It would be a good idea to draw this picture down. You don't have to draw the whole long one. You can make a shorter version in your notebook.
And because this is the advanced level content, if you have questions or you're not quite sure you understand this content, come talk to us. Do not sit there and pretend like you have it when you have no clue still.
Yep, because it just gets harder from here. This is the first video, remember? Okay. Here's an interesting tidbit. With magnets, say you're super strong, like me, and I'm able to break this magnet in half, which I totally could, I'm just choosing not to. If I break this magnet in half, each piece becomes its own little magnet also. Think about this. Pretend those are all like lines of cars. If I separate those line of cars right in the middle, there's still domains aligned. So you get domains aligned here and domains aligned here. So we just create a new South Pole and a new North Pole. If I break it again, because I'm really strong, totally am. If I break it again right here, each of those becomes a magnet too.
So just think about it. Every time you break the magnet, there's still always a front and a back of the magnet. So you will always have a north and a south.
Yeah, you can't separate someone's backside from their front side.
Right. That would be weird.
Totally. Okay, kiddos, this is your first set of notes. Make sure you have it complete. Any other thoughts?
Ask questions if you have them. Do not sit there and act like you've got it when you don't.
And if your notes aren't legible, do them over again. There's no point in something that's too sloppy.
That's right.
Later, skater.
See ya.
Is that the right button? How do I end it?
F10, I thought.
Okay, it's thinking.